Hey everybody, this is a video on polynomial long division. I'm going to have two examples in here that are ones we did in last class just for review in case you want to look at them again. And then I am going to have a few more examples that go into weirder variations of polynomial division at the end. So feel free to skip the first two examples and go straight to those last ones if you want to. We're going to start, though, with just a little bit of terminology review. So in front of us, you can see that we have a division problem. And when doing a division problem, there are three terms here. We have a dividend. We have a divisor. And we have a quotient in green. So in particular, right, the dividend is the number that's getting something divided into it, right? So 7 divided by 2, 7 is the dividend. 2 is the divisor, it's the number going into 7. And then 3 is our quotient, it's the number of times 2 went into 7. But you'll notice there's this 1/2 over here, and the number in orange is the remainder. And this number in blue down here is also the divisor, right? So we often add on the remainder divided by the divisor here, this 1/2, to our quotient, right, to make it more accurate. Sometimes we prefer to just talk about things just in terms of the remainder, to say that 2 goes into 7 3 times with the remainder of 1, and sometimes we prefer to say that 2 goes into 7 3.5 times. In our work, we're going to be using the remainder divided by divisor format for all our answers. Let's move on to the first example. So this is one that we looked at in class, and in it, we are just going to divide x plus 6 into 3x squared plus 3x minus 7, and we want to find the quotient and remainder. So first we'll set this up. We'll put the divisor outside the house. Excuse me, but I just have never been able to leave behind the inside and outside the house terminology for dividing. Don't know why. I guess that really just stuck with like 4th grade Kevin or whatever, 3rd grade Kevin. All right. So we start this problem by asking ourselves, how many times does x fit into 3x squared? Or another way of saying the same thing, what do I have to multiply x by right here in order to make it 3x squared? The answer, of course, is 3x. And just like in long division, we're going to take this 3x term on top and we're going to multiply it by our entire divisor. So 3x times x gives us 3x squared, which is exactly what we want. We want these two terms to cancel out. And 3x times 6 is going to give us 18. We will then subtract this whole line. So 3x squared minus 3x squared gives us 0, which I'm not going to write. And then 3x minus 18 is going to give us negative, I'm sorry, I forgot an x here, is going to give us minus 15x. And just like in long division, we will drop the negative 7 down to make the new line. I don't like the way this one looks. I'm going to fix that really quick. And now we're going to ask ourselves, okay, well, what times x makes negative 15x? And I'd say, well, x times negative 15 makes negative 15x. So we would then do what we did before and multiply this negative 15 by x plus 6. So negative 15 times x makes negative 15x. No surprise. Negative 15 times 6 makes negative 60. And we will subtract. These two terms will cancel, right? Because a negative minus a negative is a positive. So that makes these cancel. And then negative 7 minus negative 60, or really negative 7 plus 60, is going to give us 53. And then we'd say, well, there is nothing that I can multiply x by to turn it into 53. So this 53 is just my remainder. And I would write my final answer as 3x minus 15, my quotient, plus my remainder, 53, divided by my divisor, x plus 6. And so I just want to remind you all again that this 53 over x plus 6, it's really just like the 1/2 over here. Okay, and we're done. And we know that if you now take 3x minus 15 and you multiply it by x plus 6, then add 53 over x plus 6, you'll end up with the stuff in the house over here, right? The dividend. Next up, we have a longer problem, but this one, even though it's longer, will still be relatively straightforward. The first thing you'll probably notice is that my divisor has 3 terms instead of 2. Won't be a problem for us. All right, let's set this up. So 2x squared plus 3x plus 7, and we're gonna divide that into 2x to the 4th plus 11x cubed plus 9x squared plus 3x minus 35. So you're probably trying to figure out, well, how is having 3 terms in my divisor going to affect this problem? And I'll tell you, there's only going to really be one change. Whereas before, in the previous problem, we would subtract here 2 terms. Now we're going to be subtracting 3. All right, we'll start as we normally do. And we will ask ourselves, well, what do I have to multiply 2x squared by? It's 2x squared. What do we have to multiply 2x squared by to make it equal to 2x to the 4th? In this case, you're probably saying it's x squared. You'd be right. Then we're going to multiply x squared, just like we did before, by every term in the divisor. So x squared times 2x squared is 2x to the 4th. X squared times 3x is 3x cubed. And x squared times 7 is 7x squared. We will subtract here and see how much we have left. So as we know, these first two terms cancel. If they ever don't cancel, you've done something wrong. Then 11x cubed minus 3x cubed gives us, 8, not 7, 8x cubed. And we'll have 9x squared minus 7x squared will give us plus 2x squared. As before, we're just going to drop the next term. And we'll start the process over again. We'll ask, what do I have to multiply 2x squared by to turn it into 8x cubed? And you would probably say 4x. We'll then multiply 4x by all the terms in the divisor. So 4x times 2x squared is what we're looking for, 8x cubed. 4x times 3x is 12x squared. And 4x times 7 is 28x. I'll subtract. We get 0 here. 2x squared minus 12x squared is going to give us negative 10x squared. And 3x minus 28x is going to give us negative 25x. We'll then drop the negative 35, and we're almost done. We can say, well, okay, 2x squared is going to go into negative 10x squared, negative 5 times, right? Or in other words, negative 5 times 2x squared gives us negative 10x squared. And we'll multiply negative 5 by every term in the divisor, so negative 5 times 2x squared gives us what we expect. Negative 5 times 3x gives us negative 15x. And negative 5 times 7 gives us negative 35. We'll subtract. These first column cancels. Second column gives us 10x, and the third column gives us 0, in fact. So I won't bother to write it. And there's no other numbers to drop over here. And so it's looking like 10x is our remainder, because there's nothing I can multiply 2x squared by to turn it into just 10x, right? This x here is has a lower degree than the leading term of the divisor. So we are done when we see that happen here. And so our final answer is just going to be x squared plus 4x minus 5 plus 10x over our divisor, 2x squared plus 3x plus 7. And we are done. So again, we know if we multiply x squared plus 4x minus 5 plus this business by our divisor, we should get back our original equation. Let me extend this division line here. Okay. So these two should be hopefully familiar from class. I believe I talked about one like example 2 in class. And now let's go into some of the variations or like the special cases. Okay, so this third example we definitely did talk about, but I think it's worth going over again. Let's set this problem up. And so x minus 2 is going to be divided into x cubed. So the first thing you'll notice about this problem is that you only have one term in your dividend. That's weird. We haven't seen a problem quite like this in our examples today. Well, if you're in order for polynomial division to work, or I should say in order for the algorithm to work, you need to have nice descending powers on your terms. In order to get that in this problem, right, I have x cubed, but I don't have an x squared, an x, or a constant. So I'm just going to add in 0 terms here. So I'm going to add in a 0x squared. I'm going to add in a 0x. And I'm going to add in a 0 just as a final constant. And this is for bookkeeping. If I'm ever missing any power in here, right? First power over here, second power, something like that, I have to add it in as a 0 term. And we'll look at that more in the next example. But for this one, it's pretty straightforward to do. You just got to add in the missing terms. So the rest of this problem will proceed normally. We'll ask, what do I have to multiply x by to turn it into x cubed? That is x squared. Then we'll multiply x squared by the divisor. So x squared times x gives us x cubed. X squared times negative 2 gives us negative 2x squared. We will subtract, as we typically do. And we'll be left with 2x squared down here, right? Subtracting a negative gives us a positive 2. We'll bring down the next term, which is just 0x. And we'll say, what do I have to multiply x by to make 2x squared? And we'll say, well, okay, that's just 2x. We'll multiply 2x by the divisor, and we'll get this. We will subtract. And we'll be left with 4x. We'll bring down the next term, which is just 0. And we'll say, how many times does x, or what do I have to multiply x by to get 4x? If you say 4, you'd be correct. 4 times x gives us 4x. 4 times negative 2 gives us negative 8. We subtract. And you end up with 8 as your remainder here. So our final answer, again, is x squared plus 2x plus 4 plus 8 over x minus 2. And what this means is that if I take my quotient here, or this whole answer, and I multiply it by x minus 2, I'll get back x cubed. Finally, or actually no, I got 2 more examples left. This is another example of polynomials that are missing terms and how to handle them. It works actually a lot like the last problem. So first, you'll notice in the divisor over here, the x squared minus 1, we're missing the x term, right? We have x squared, we have a constant, but we don't have an x to the first term. So we're going to have to add that in when we set up our problem. Right, so this nice descending powers is necessary regardless of if we're missing something in the divisor or in the dividend over here. And then you'll notice the dividend is also missing two terms, right? It's missing an x cubed and it's missing an x term. So we're going to have to add both of those in as well. So we'll have x to the fourth minus 0x cubed minus 3x squared plus x, plus 0x, and then plus 1. So really, we really just need to add these 0 terms for bookkeeping's sake. Like I said, it keeps everything nice and lined up. We don't end up in a confusing situation. I actually believe this particular problem might work out if you don't add in the zeros, but that's a special case. I would always add them in anyway. All right, so we're going to proceed like we normally do. We look at our leading term of our divisor, x squared, and we say, what do we have to multiply it by to make x to the fourth? That's x squared. And we multiply x squared by our entire divisor. Notice when we multiply x squared by this 0x, we're going to get 0x cubed. And then x squared minus negative 1 is minus x squared. We'll subtract. Notice we get 0 over here, but we'll also get 0 over here. And there's a couple ways to handle the 0 over here. I'm going to show the very by the book method for this particular video. So I'm going to actually write in the 0x cubed. You don't technically have to, but I'm going to. And then I'll get this last term. What is that going to be? Minus 2x squared, I believe. And technically speaking, you want just the first term here to cancel out. If the second term cancels, I'll often leave it as a 0. Again, for bookkeeping's sake, I'll drop my next term. And then I'll say, okay, what do I have to multiply x squared by to get 0x cubed? I'm going to say it's kind of silly, but it's 0x. So 0x times 0x squared is going to give us 0x cubed. 0x times 0x is going to give us 0x squared. 0x times negative 1 is going to give us minus, it's going to be 0. You could have just written this entire line as zeros if you wanted to. By the way, you didn't have to put the x's in here. Okay. Oh, I'm sorry, I'm going to do this as 0. Okay. So we subtract, and you'll see silly things happen, right? We're just going to end up with negative 2x squared plus 0x, or minus, doesn't matter. And then we'll drop the next term, the 1. So that was like a silly step in here, but like I said, we're doing it because it keeps everything nice and lined up for the division. It's really just useful when using this particular algorithm. There are actually other algorithms for polynomial division, and some of them can dispense with this step. Anyway, let's continue. So next we're going to ask the same question we always ask. Well, I have to multiply my leading term here, x squared, by to get negative 2x squared in this case. Well, that's just negative 2. So we'll have negative 2 now times our whole divisor. And then plus 0x. And then negative 2 times negative 1 is plus 1. And you'll notice here that when we subtract, we end up with 0. Hey, there's no remainder. That's kind of cool. And so our final answer for this problem is this. I would write it, I drop the 0 up here, and I just write it as x squared minus 2 is our answer. So we have no remainder. And again, what this means is if you take x squared minus 2 and you multiply it by x squared minus 1, you end up with what we started with. You end up with x to the fourth minus 3x squared plus 1. Final example, getting a little tricky here. I like this problem a lot. You'll notice that there's an a in our dividend on top here. And what we want to know is what a should be so that there's no remainder when we divide these two polynomials. Well, how might we solve this problem? I'm going to start just by setting up as regular polynomial division and seeing what happens. hopefully we'll be able to make some inferences along the way that will make it clear to us what we should be doing, or how we can get rid of the remainder. So forging blindly ahead, we have this. I'll leave that A in green. And we'll begin like we always do. Say, what times 3x makes 6x cubed? 2x squared. We'll multiply 2x squared by our divisor. Well, yeah, minus 2x squared. Should have known that. All right. And we will subtract. And we will get 0 for the first one and 3x squared, because that subtracting a negative turns this positive. And then we'll drop our ax, and we're gonna hope that this works out for us. Ax. So we'll ask like we always do. What times 3x makes 3x squared? Well, x. And we will multiply that by our divisor, and we'll get 3x squared minus x. We'll subtract, and we'll have 3x squared and 3x squared turn into 0, and then ax minus x you can think of as, right, ax minus x is our answer here. I would actually prefer to factor out the x and rewrite this as a minus 1 times x. Maybe I'll turn this green. See how that goes for me. Green. Oh, I missed the other arm of the parentheses. I'm going to leave that green because that's going to be important to us. It's a little weird, right? But we can still technically do the problem this way. Since a is just standing in for some number we're trying to find. Okay, so we'll drop the next number. We'll drop the plus 4. And so now we're going to ask ourselves what we always ask ourselves. What times 3x should give us a minus 1x? Ooh, that's a little weird. Let you think about that for a second. Well, we know what we're really asking is, what do you have to multiply by 3 in order to turn it into a minus 1? And I can write that as a little equation on the side over here. What do I have to multiply by 3? Maybe that, we'll make that a variable. We'll call that k. So k times 3 needs to equal a minus 1. Well, in order to figure out what k is in this equation, we'll just solve for it by dividing both sides by 3. So this last term up here is going to need to be a minus 1 over 3. A minus 1 over 3 times 3x should give us just a minus 1x. And then a minus 1 over 3 minus times negative 1, just negative a minus 1 over 3. We'll subtract. Now, here's where we get to the good part over here. We'll notice that these first two terms, this first column, is all going to cancel out and be 0. And then what's left is going to be 4. And then we're going to be subtracting a negative. So we're going to be adding a minus 1 over 3. Okay. Our original question here was to figure out what value of a we need so that this has no remainder. Well, if this has no remainder, this bottom stuff right down here, do that in different color, this bottom stuff needs to be 0. So let's just set it equal to 0 and solve for a. You might even be able to see what it should be just by looking at this equation, asking what I could plug in for a that makes this whole little expression 0. So that's what we want to find, because that'll get rid of the remainder. So what value of a makes this 0? All right, well, if we want to solve this, I can bring 4 to the other side. Then I will multiply both sides of this equation by 3. Add 1. And so it looks to me like a needs to be negative 11. Because if a is negative 11, then, again, this last bit, this remainder, will be 0. And that's the problem. So sometimes you'll be asked, like I believe there's one problem in the homework that asks you to figure out a constant like this. And the overall strategy on this problem is just to do it normally. Just set it up normally, work through each step, and when you get to parts with a in them, keep going. Treat them as if it was just a number. You might have to do some trickery like I did up here with the a minus 1 over 3 in order to get some of the algebra to work out, but it will work out. I do promise you. All right. And then the final step is when, if you're asked to find something that doesn't have a remainder, then you're going to get to that final step with your remainder and then figure out what you plug in for a to make the remainder 0. Or if someone wants us to have a remainder of 10, we could figure out what we'd have to plug in to get 10 as our remainder. That concludes this video, folks. Thank you for watching, and good luck with the homework. Please come by office hours on Monday if you have problems or questions. I'd be happy to answer any of them. Wait, no, not Monday. I'm sorry. You guys are a big class. We're doing meetings Thursday, Friday, and Monday. So come by office hours on Tuesday if you have questions on this homework. And and I'll see you all guys again as a group on next Thursday. Have a good one.